All right, page 2 of the sample test. So here's a price one and quantity. In quantity I used Q instead of X like we did in the book. And it says write a revenue equation. Well, revenue is quantity times price. The quantity sold times the price you set it at. So it didn't say write it as a function of P or of Q, so we could do it either way, and since it says P is equal to this, I can put that in for P, and I would have a revenue equation as a function of Q that would be Q times P, but P is 3,500 minus 5Q. Now, if I asked for a revenue function that was a function of P, then I would have to replace the Q and leave the P, so I'd have the P times, and I would take this equation and turn it around so that it has Q by itself, and I want to show you how to do that. So I'm going to pull up another piece of paper here, and I would have P is 3,500 minus 5Q. So if I'm solving for Q, I would subtract 3,500. So I'd have P minus 3,500, subtracting 3,500 from both sides, equals negative 5Q. Then I would divide everything by negative 5, and I would get negative P divided by 5, or negative 1/5 P. That's what I would get if I divided P by 5. I'd get 1/5 of P. And negative 3,500 divided by negative 5 is going to be positive 700. And that's what Q would be. And now I could write a function of P by replacing the Q with this expression. Minus 1/5 P plus 700. So in this problem, I didn't say write it as a function of Q or P. So you can do whichever one you want. So now I'm going to do the rest of the problems using both of these equations so you can see how you could do it with either one. It says determine the price that produces the maximum revenue. Well, if I did this one, then I'd have the revenue as a function of the price, and I'm trying to find the maximum revenue price, so I would just keep working with this. I'd write this as a parabola, minus 1/5 P squared plus 700 P, and the price that produces the maximum would be at the vertex, so I'd find the vertex of this by doing minus B, the opposite of B, 700, the opposite 7, over 2A, so divided by a negative 2 times 1/5 is negative 2/5. So that would be, let's see, if I can do this in my head, that'd be 3 multiplied by 5, that's 3,500 divided by 2, which is 1750, I think. So the price would have to be 1750, I believe, because that's what we're solving for P. Let me just check that real quickly. To type that in, you would go negative 700 divided by parenthesis negative 2 divided by 5, close parenthesis, 1750, yes. So this must be an expensive item because it's costing us $17.50 per item. That would be the price that produces maximum. Now, if I'd worked with the other equation, P, see, this one up here, P, the revenue as a function of Q, is, so this would be negative 5Q squared plus 3,500Q. And I can get the quantity that produces the highest price by doing the opposite of B over 2 times A, which would be 2 times -5 would be -10. And that would come out to be 350 is the quantity that produces the maximum revenue. And then I could take that back into the original equation for the price, put 350 in for the quantity, take it times 5, and that would be 1750. Take it from, subtract that from 3,500, and I would get 1750. So, the price is 1750. I can get it from the quantity going from that side. So the price that produced the maximum revenue would be 1750. Determine the quantity sold at the maximum revenue. Well, if we did this, we could put that in for the price and solve for Q, or we could just use this equation and do what I did, and you get the quantity is 350 is the quantity sold that produces the maximum price. And so the maximum revenue, I can either put 1750 back in for the price in this one, or 350 into for the quantity in this one, or do the easy part now. Since I have both the price and the quantity, I can just multiply these and get the maximum revenue. 1750 times 350. 350 items at 1750 per item is a revenue of 612,500. Assuming this is in dollars. All right, 7. I've made a table. It says make a scatter plot. Okay, so I need to look at my x's. They go from almost 0 to up to 4. So I'm going to go 0, let's see, 1, 2, 1.51, 2, 3, 4. That would use a fair amount of the graph. The y's, go, they're all negative, so I'll probably want to make the x-axis up high and do my y's. See, the smallest y is -18, so if I go negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, I probably should have put it higher, 15, 16, 17, 18 is clear down here, so I'll make this be my y-axis. Here's my units for the x direction, and these are all negative. And so 2.2 would be about here, and -4.5 would be about there. There's my first point. 3.5 is here and down 8, so that's down 3, 4, 5, 6, 7, 8.3. That's just a little bit below at 3.5. 4 is -9.7. -9.7 would be about there. 1.2 is -1.6. -1.6 would be about here. This height at 1.2 would be about there. 5.4, 4, 5, I didn't see that one, 5.4, so there's 5, 5.5, 5.4 is just short of it. It's going to be at negative 13. There's negative 13.6. That's about there. 7. Oh, 6. 7. I got to go clear out here. It's at negative 18. That's down here. At 0.7, it's at negative 0.1, which would be right about there. And 2.9, it's at negative 6.5, which is about there. Okay, I made the scatter plot. Determine whether a linear model or a quadratic model would better fit this. Well, looking at this and how carefully I drew it, it looks to me like this is pretty much a straight line. So I'd explain that it looks like a straight line, so I'm going to use a linear model. Now I'm going to determine that model, and you can use your calculator, or you could pick 2 points that you think are pretty close and do it with manually. Some of you don't have a calculator, so you would pick 2 points that are pretty close to the line. Doing the quadratic model would be even tougher, but the linear model, I would type all those in there. And okay, let me just go ahead and do that because some of you struggle with this still. So I'm going to push Stat, Edit, and I'm going to put the numbers in here. 2.2, 3.5, 4, 1.2, 5.4, 7.7, 2.9. Then I'm going to go to the list 2, and it's going to be negative 4.5, negative 8.3, negative 9.7, negative 1.6, negative 13.6, negative 18, negative 0.1, negative 6.5. And if I turn the stat plot on, number 1, turn it on, scatter plot using list 1 and 2, then zoom 9, I can see this should look a lot like what I just did. It's drawing a graph because I got an equation there, so I'll clear that. There's the graph, and it looks similar, just a different scale, similar. And now we go Stat, calculate the line that goes through using the list 1 as the x's, list 2 as the y's, and if I want to, comma, vars, y variables, function, put it into y1, put the equation when it gets it, so I press enter, and it says the slope should be negative 2.84 x plus 1.77 for the y-intercept. And that's my linear model. And if I had diagnostics on, second catalog, alpha D for diagnostics, diagnostics on, enter, second quit. And if I do it again, it'll tell me the R value, which is really close to 1, so it's a pretty good fit. And that's the equation. It's a linear model. What did I do? Oh, let's take a look at the graph and just see how well it fit. There it is. Pretty much right through all the points. Okay.